combined footing. So I will read the problem and I will explain the design in this video. Design a combined rectangular footing for two columns. So the combined footing is for two columns, okay, C1 and C2 spaced at 3 meter apart, carrying the following service load. So the center to center distance between the column is 3 meter, and the service load is given as follows. Column C1 C2, size of the column is given, what material they have used, concrete material for C1 C2 is given, and what are the reinforcement, the diameter and the number of reinforcement is also given. Dead load of the column and live load of the column is given. So all the given load is service load. Okay, the problem continues. The width of the base shall not exceed 2 meter. So see, in the combined footing, this is the planned dimension of the combined footing. Okay, so this is the L that we need to find, and B is restricted. You cannot exceed B more than 2. Either you can make it up to 2 or less than 2. So B is restricted. So what you can do here, you can take B equal to 2 meter. Okay, so L into B equal to A. If you know area, you know B, you can find length. Okay, so this thing we need to calculate. So the width of the base shall not exceed 2 meter. The allowable bearing pressure on soil is 175 kilonewton per meter square. So means it's SBC, safe bearing capacity of the soil, is also equal to the allowable bearing capacity of the soil. Footing material, so we also have to define the footing material, M20 grade concrete and HYSD reinforcement of Fe415. So the very first step in this problem, now the question is over. Now we have to switch over to the design. The very first step in this is area of the footing. Now see, whenever you calculate area of the footing, I told you when I explained the pad footing, whenever you are calculating area of the footing, you have to take the service load. Okay, service load you have to take. So whatever load they have given, it is service load. So total service load on footing, is 480 plus 170, the live load, dead load of the column plus live load of the column C1 plus this is dead load of the column C2 plus live load of the column C2. So whatever load they have given, it is service load. So this is the total quantity of the service load they have given. Now you see, the self weight of the combined footing, obviously it will be more than the pad footing. So in case of pad footing, we are assuming 10%. Now we have to assume more percentage of the self weight of more percentage of this load as self weight of the footing. So in this case, we are assuming 12% of this load as a self weight of the footing. So 12% of this load you are getting 175. The total load is 1625 kilonewton. So area of the footing is calculated by total load including the self weight of the footing divided by SBC, safe bearing capacity, equal to 9.28 meter square. So this is the area that we need to design. This is the minimum required area. Okay, so I will turn the page. Now you see here, what is given here, width of the footing is given. You can restrict, it is given in the problem that the width of the footing should be 2 meter, or it is restricted to 2 meter. You cannot take more than that. And the length of the footing, so you have to find like this: L into B equal to area. Area you have calculated, you can take from the previous step, you have calculated, which is 9.28. so B is 2, you can find L. So this is the minimum required L. You can provide more than this. Okay, now see here, the next part, considering the columns carrying total load and the CG of the column load from C1. Now see, we have two columns, C1 C2. Okay, C1 C2, we need to determine the CG of the column C1 and C2. For that we are taking that we are assuming total load P, which is equal to C1 and C2, acting at a distance x from C1 column. Okay, so we need to find this x distance. So for that we apply Varignon's theorem. You know what is Varignon's theorem? The moment of the resultant about any point is equal to sum of the moment of the forces. So what we will be doing here, we will be taking moment about this point. Moment about this point is C2 into 3 equal to the moment of resultant. So only one force is acting here. C2 is 800 into 3 equal to moment of resultant. What is the moment of resultant? P into x. P into x is P. What is P? P equal to C1 plus C2. C1 plus C2. So you will be getting x distance. Okay. So x distance is 1.66. 1.66 is nothing but the CG from the distance of CG of the load from C1. C1 means center of C1 column. So you can see here this distance, this is the CG of the footing, and also at this point the load is acting. So this distance is 1.66 meter we have calculated, and you can increase the length little bit you can increase. So the minimum required length is 4.64. You can increase little bit. You can provide 4.7, 4.8, and you can increase. That is the minimum required length. Now see here, 1.66 plus 0.89. So what you are getting here? 1.66 plus 0.89.